What are the challenges of debugging in field embedded devices? Imagine trying to fix a complex machine while it is operating in a remote location without direct access. This scenario captures the essence of debugging in field embedded devices, which are often deployed in environments where traditional troubleshooting methods are not feasible. These devices are integral to many systems, from industrial automation to medical equipment, and ensuring their proper function is critical. However, several unique challenges make identifying and resolving issues in these devices particularly demanding. One major obstacle is limited access to the hardware. Unlike laboratory settings, in-field devices are often installed in hard-to-reach locations such as inside machinery, underground, or in hazardous environments. This physical inaccessibility complicates the process of connecting diagnostic tools or performing hardware inspections. Additionally, many embedded systems operate with minimal physical interfaces, sometimes only offering a few pins or ports for debugging purposes, which restricts the ability to perform comprehensive hardware diagnostics. Another significant challenge involves resource constraints. Embedded devices are typically designed to be cost-effective and energy efficient, which means they have limited processing power, memory, and storage capacity. These restrictions can hinder the implementation of sophisticated debugging tools or real-time monitoring systems. As a result, developers often relying on lightweight logging or simple status indicators, which may not provide enough detailed information to pinpoint complex issues. Communication limitations also play a crucial role. In many cases, these devices are located in areas with poor or intermittent network connectivity. This makes remote debugging difficult, as data transmission might be slow, unreliable, or unavailable altogether. When connectivity is compromised, developers cannot easily access real-time data or deploy updates, prolonging the time to resolve faults. Environmental factors further complicate debugging efforts. In-field devices are exposed to harsh conditions such as extreme temperatures, humidity, dust, or vibrations. These factors can cause hardware degradation or intermittent faults that are difficult to reproduce or diagnose in controlled environments. The variability of these conditions often leads to sporadic issues that are challenging to replicate during troubleshooting. Lastly, the complexity of embedded software itself can pose difficulties. Firmware and embedded operating systems are often highly optimized and tailored to specific hardware, making debugging a delicate process. Bugs may be deeply embedded within low-level code, and traditional debugging tools may not be compatible or feasible to use in the field. Developers might need to rely on specialized tools or techniques, such as in-system programming or on-chip debugging interfaces, which requiring additional expertise and planning. In summary, debugging in field embedded devices involves overcoming physical accessibility issues, resource limitations, communication barriers, environmental challenges, and software complexity. Each of these factors demands innovative approaches and careful planning to ensure these vital systems remain as operational and reliable.